All right, so today we're going to talk about our new unit, and our new unit is going to actually span a couple of weeks, all right, and we're going to break it up into three separate things. We're going to have the first three lessons this week. We'll talk about rational expressions and equations, which if you think about the word rational, what word is in there? Ration. Really? Math word. Ratio, right? Ration? No, we're not wartime. Okay, ratio. All right, which means when you think about a ratio, most people think about fractions. All right, you can think about a colon, that's fine, but most people think about, you say ellipses with the ... You're not making any sense, Guillermo. Okay, so we're going to be talking about rational expressions today. All right, so we'll be looking at simplifying them in the first section, and then in the second micro lecture, we'll be looking at multiplying and dividing them. Now, you're going to see multiplication and division is the same thing as just simplifying, just a lot more work. All right, so notice right here, these are all examples of rational expressions. So what about them is interesting or something you've never seen before?
They're fractions.
They're fractions, but more importantly, yeah, sometimes that's the case. But most importantly, if you look in the denominators, what do you see in the denominators? They all have a variable. All right? So that will be the difference. This unit that you've never seen before, or maybe you have but just not familiar with them, we must have variables in the denominator. Now, which means we have to be careful. Because if this is a fraction, right, if this is a ratio, and we have variables in the denominator, we cannot divide by what number? 0. All right, so we have to make sure that we talk about the values for x or whatever variable that make the denominator 0, because it cannot be that number. All right, it can be any number you want it to be, except for anything that makes the denominator become 0. All right, so keep that in mind. We will be talking about that. So let's look at this first example. Bless you. It says to simplify. Let's do that first, and we'll talk about the second part. So how do you think we want to simplify this? Factor. Right? What did you guys do in the second part of the rewind? Factored. You factored. All right. So what do we know about x squared minus 4x? What do those have in common? They have an x. I'm going to factor out x. And what is left?
X minus 4.
All right. How can you make sure that you factored correctly? Distribute it mentally. So x times x is x squared. X times negative 4, negative 4. So that's how you can always check to make sure you factored correctly. All right, what about the denominator?
A times c.
Yes, I would. If you're having trouble with this, I would say remember our phrase: factors of a times c that add to b. All right. Now again, when you have what in front of x squared, does it make it a little bit more simple? When there's a 1 here, do I really care about a? No, I just care about factors of c that add to b. All right, but if there's not a 1 here, then you need to make sure you include that in that phrase. All right, so what are factors of negative 8 that add to negative 2? Negative 4 and positive 2. Very good. So x plus 2 and x minus 4. Again, you should be able to distribute that mentally in your head. X times x. Negative 4x plus 2x is negative 2x and negative 8. All right, so distribute that mentally in your head. Now, you should notice something happened when we factored. We can cross out two factors because we have an x minus 4 over an x minus 4. So those will divide to make 1. All right, so those are gone. All right, so we get to cross them out. Which means what is left? X over x plus 2. Why can we not cross out these x's? That's a great question.
Because you want to find out what x is.
Well, no, we can, but we want to do the same thing here, right? The idea is that they have to be exactly the same factor. And what's this factor? And what's this factor? Are those the same? No. The most common mistake that I see with students when doing this, all right, and no one said this at the beginning, but the most common mistake I see is at the very beginning, students will go like this and cross out the x squareds. Yeah, can't do that. right? That's a surefire way to make me cry on your paper, okay? So let's not do that. All right, so you want to factor everything. Now that we've simplified, what does the second part of the example ask us to do?
Identify any x value.
There's more words.
Or ways the expression is undefined.
Very good. So what does that mean we need to do?
Identify.
We need to figure out what values for x are going to do what? Make what? Make it undefined. So what makes it undefined? Dividing by what?
0.
Dividing by 0. So you need to find what values for x make
0.
0 where?
Denominator.
In the denominator. So I'm going to go back to my answer here. I'm going to write a comma, and x cannot be equal to, well, what can x not be equal to make 0 here in the bottom? -2. And a lot of us would move on.
No.
But we actually had something else in the bottom before we simplified. What did we have in the bottom before we crossed it out? We had x minus 4. So what makes that become 0? So not only is it -2, but x cannot be equal to 4. All right, so make sure that even if you cross something out, it's still included when you do your values that make it undefined. All right, does everyone see the two pieces there? You got to simplify it and then identify the values that would make your denominator become 0.